Hello friends, this is Dr. MiteshGala, presently teaching in Campaign School. Welcome to the online teaching resource.
Hi, we are getting into exercise 21A, surface area, volume and capacity. Now here there are three objects, cube, cuboid and cylinder. I will teach you how to work out the cylinder, although it is not there. We are just doing first three exercises, A, B and C. But still I'll teach you the formulae how to get for all the three. Now this I have taught in standard 10 one of the videos. So I have edited one part from there to make you understand what is surface area, total surface area, curved surface area, as well as what is the volume. So look at that video after this. You will get to know what are the three things and how to derive these formulae. Look at that small table in which I have shown you cube, cuboid and cylinder, all the three derivation and the formulae. Learn them well and then come back for this video. So it's just after this you will see this. Now before we get into this topic, few things are to be known very clearly. Alright, this is a shape which you can see, hollow from this side, right? What shape is this? Not a rectangle. Rectangle, squares, all these are two-dimensional figures. Means only length and breadth. So this one face is a rectangle. But this entire object is a solid because it has three dimensions, that namely length, breadth and this height. Which height is missing in a rectangle. Here it is there, therefore 3 dimensions, so 3D figure, alright. So this is called as a cuboid, alright. Now when you talk about the surface, then you're talking about surface area. But when you talk about volume, then you're talking about this inner hollow space which is right inside over there, alright. So surface area and the volume. So volume for any object which is a 3-dimensional figure is the inside available space, whereas surface area means surface ka area. Alright. Now if you look at this object, it has got 1, this side 2, 1, 2, 3 and 4 vertical faces. Vertical means straight faces, and 1 and 2 horizontal faces. So 4 vertical faces, 2 horizontal faces. Are you getting it? So first, surface area is the area available on the surface. You have two types in this: area of vertical faces which are straight, and you can say total surface area, that is all your faces. Alright, so that's part 1. Part 2 is the volume. So volume basically is the inside available space, or you can say space that is available inside. So whenever you want to find out what is the volume, okay, or what is the amount of water, or what is the amount of objects that can stay inside, or the amount of air that can stay inside, basically you are talking about volume. Are we clear with these two concepts first? Okay, now let's get into each of the objects. So here the first object that I have taken is basically a cube. Cube is consisting of squares. 6 squares together make one cube. So here first square I have made it in red. Then you have second, third, and likewise 3 more on the other side of the face. So 6 faces, alright. Now for a square or for a cube where all sides are equal, so we will call all of them as length. So length, length and length. So length, breadth and height all are length only because all are same. So when I pull out one square, so surface area of one square, so area of a square is equal to side square. Now 2 parts in surface area we said, area of vertical faces. So how many vertical faces does this have? 4 vertical faces, 1, 2 and the other 2 on the other side. This is a horizontal face, alright. So one face is L square, so 4 faces will be 4L square, right? Likewise total surface area. So total surface area will be all faces. So one square, like that 6 squares we said, therefore 6L square. And finally the volume. So volume is the inside available space. For that what you do is length, breadth into height. So length into breadth into height. In this case all 3 are same and therefore L cube. Are we clear with this? So that is called as your cube, where all are basically 6 squares which form a cube, or you can say 6 faces. Out of that, 4 vertical and 2 horizontal, when added to this, total becomes 6, and volume is length, breadth, height. So are we clear with the first one at least? That is a cuboid. Sorry, cube. Now let's get into the next one. That is a cuboid. So what's a cuboid? So before we go on to the cuboid, let us continuously keep on updating. Basically in this topic, you are going to understand 6 major solids: cube, cuboid, cylinder, cone, sphere and hemisphere. What are these 4? We will get onto that gradually, so don't bother about it. So first, for the cube, can you tell me area of vertical faces for a cube? 4 vertical faces right now taught. Very good. 4L square. Likewise, can you tell me total surface area? 6L square, 6 pieces. And volume that we just now derived? L cube. Perfect. I want you to pay attention completely to this part when I am explaining you the derivation of most of the formulae, so that it registers very well in your head. Once you know these formulae, the topic is very simple. But if you do not know, then it's going to be a nightmare. So let's go on to the next shape. That is a cuboid. Now this is your cuboid. How does your cuboid look? So cuboid is basically 6 rectangles, but all of different shape and size, right? So here you have the length, this you have the breadth, alright, and this you have the height. So length, breadth and height. I'm pulling out this first one. All rectangles will be 2, one on this side, one on the other side, 2 of same shape and size, one on this side, second on the other side, one on this side and one at the bottom, but 6 in all together. Alright, so this is the first one, length, and this is called as the height. The second one, breadth and the height, and the third one on top, so this is length and this is your breadth. Alright, so 3 different shapes is what we are getting. Basically not shapes, 3 different dimensions, but all 3 are rectangle. Right now different shapes they look, because I had drawn it like that to show you a 3D figure, but technically these 2 are rectangles only. Alright, now 4 vertical faces here also. So we are first understanding surface area, right? And this is called as a cuboid. Cube, where all rectangles are same, basically squares, and cuboid, all are rectangles. Alright, so now the first one. Now you need to find area of vertical faces. So how many vertical faces? 4. So we will say area of vertical faces. Now this is the first vertical face, this is the second, this is the horizontal one, correct? So the first vertical face, length into height. And how many such vertical faces? 2, one on this side, one on the other side. The second one is this vertical face, this is horizontal. So the second one, plus breadth into height, and there are 2 such, one on this side, one on this side. So you add these 2. When you do this, what are you going to get is only area of vertical faces, the vertical faces. When you look at the room around that you are sitting in right now, you will see 4 walls. Those 4 walls, look around, look around. Those 4 walls are called as the vertical faces, whereas the ceiling and the bottom, that is your floor, both are your horizontal faces. Okay. Now what can you pull out common here? So I can pull out 2 common, I can pull out H common. What is left is L plus B. Now I'm not writing 2H together, just to make you understand that this is nothing else but perimeter, twice length plus breadth into height. So whenever you want to find the area, basically you take perimeter of one side and multiply it with the height. Alright, so that is area of vertical faces. Now what if I want to find total surface area? So what am I going to do? So let's see. For total surface area, total surface area. So total surface area obviously is going to be these 2 plus this one. So first length into height, which we already had, breadth into height. So we got 4 vertical faces. Now the top and the bottom. So the top is here, length into breadth. So length into breadth, but 2 times, because one on top, one at the bottom. What can I pull common is 2. What will be left is LB, BH, HL. I'm writing it in order so that we can remember LB, then BH, and then HL. So that's your total surface area. See how quickly we derived it without learning it also. So you should be deriving all these, then it's fun. And finally the volume. So volume is basically going to be length into breadth into height. We already know that LBH. So nothing great. So I hope I made you understand how to go about with the different parts of a cuboid. So I hope you remember all these formulae. vertical faces, total surface area and the volume. Got it? So let's fill up the table. Come on, let's see if you could remember all this. Anybody, what is the area of vertical faces for a cuboid? Come on, can you? Perfect. Twice length plus breadth into height. What about total surface area? So twice LB plus BH plus HL. And what about the volume? LBH. So we've learned at least 6 formulas straight away. You need to learn all these. Don't worry, I'll make it very simple for you provided you are with me. If you're not with me, I can't help it, alright? So let's go on with the next one. Is the cylinder. Now how does your cylinder look like? Cylinder is anything like this. Can you see? Yeah, a circle on top, and like this circular is a cylinder, just like your pipe or even the pen or pencil that you are holding. So that's a cylinder. For a cylinder, the figure will look like this. Okay, I have made a 3D figure to make you understand, and this is the original figure. These are the two circles, one at the bottom and one on the top. Alright, so that's your cylinder. Now for a cylinder, you don't have area of vertical faces because these are not faces, it's a circle. So therefore, for a cylinder, what do you have is called as curved surface area. Now what is a curved surface area? CSA. Now curved surface area, to understand that, we'll have to open this cylinder and see. So when we open this cylinder, what shape will it become? Can you predict? Okay, let me open the cylinder and then let's see what shape does it become. So I'm opening the first side and the second side. There you go. So I'm opening this and you tell me what shape did it become. Can you see? That was a cylinder, and when I opened it, it becomes the shape of a rectangle. Can you believe it? It's a rectangle, this part, one circle on top and one circle at the bottom. So that's your curved surface area, this. When you add these two to it, it will become total surface area. And then the space available inside is the volume. So first let's see curved surface area. So basically length into breadth should be the curved surface area, am I right? But to get length and breadth, length, when I make this, the same length becomes what? Circumference, superb. And the same breadth now becomes what? The height of the cylinder. Can you see the height? So it's basically circumference into height, that is length into breadth. So circumference is what? 2 pi r into height. That's your formula. Did we make it simple? Likewise, one circle ka area is pi r square. Another circle ka area, another pi r square. So now if you wish to find total surface area, you will take the curved surface area, that is this entire region, plus this circle, plus this circle. So two circles, so 2 times pi r square. What can I pull out common? So 2 pi r can be pulled common. H plus r is left. So you got the formula for total surface area. Did I make it really simple? Come on, now you can pull it up. Finally, the volume. So volume will be what? It's the inner space available. Now for volume, I want you to understand one thing. When you keep on stacking 5 rupees coin one on the other, what shape does it become at the end? Let's say if you stack 10 coins, it will become a cylinder. Can you see cylindrical shape? Can you imagine that? So if you take one perimeter or one circumference and multiply it into height, one circumference and multiply it into height, you will get the total surface area. Exactly, that's what is here. So 2 pi r into height is what you will get. Okay. And now for the volume, you need to understand this very carefully. For volume, you have to take one circle ka surface area and the number of circles that are there inside. So automatically what you will get is the inner volume. So one area is pi r square. Circle ka area is pi r square into height. That's the formula. So one circle into the number of circles that go inside. That's very, very important. Alright. So you got curved surface area, total surface area, as well as the volume for the cylinder. learn it, know, understand it so you get it better. So let's go on to the table and fill it up. So can you fill it up right now for me? Come on. I would suggest you should make this table or take a printout of this rather in the start when this is empty and start filling it up on your own. So cylinder, curved surface area. This time no more vertical faces. So what will be the curved surface area for a cylinder? We just now did it, come on. So 2 pi RH. What will be the total surface area? Can you do it? 2 pi R H plus R. And the volume, pi R square H, area into height. This is 1 circumference into height. That's what your curved surface area. I taught you 1 perimeter into height is the surface area. Whereas if you want to find the volume inside, then 1 area of the circle into height. Alright? Alright, now that you're back, here you go with cuboid. So the cuboid is the first part is what we are working with. So you already know now what is surface area, what is total surface area, and what is the volume. Volume is the inside space, surface is the outside cover. When you take only the sides, vertical sides, and when you take everything, it becomes total surface. In the first exercise, we are just talking about total surface and the volume. So it's very, very simple. So cuboid 1 part 2, they say length, breadth and height are these, find the volume and total surface. Both are in meters, but this is in centimeters. So converting it into meters divided by 100. Volume, come on, pause the video, apply the formula and 100% sure you can manage it easily. So the volume is length into breadth into height. So 3.5 into 2.6 into 0.9. So a lot of calculations. So 9 6 are 54, 1823 into 35, 520, 17, 11, 12, 9 and 1, 10, 3 2 are 6 and 1, 7. So 0, 9, 1, 8. So I am getting it with 1, 2, 3 decimals as 8.190 meter cube. Please tell me if I am correct, because all the answers, yes, it's correct. All the answers here are in decimals. Total surface area, anyone the formula? Correct. Twice length plus breadth, breadth plus height, height plus length. I hope you understood the derivation well in the video previously. So length is 3.5, breadth is 2.6, likewise 2.6, 0.9, 0.9 and 3.5. Here there will be a plus sign and in brackets. So 2 times 35 into 26 we'll have to multiply. Let me take a rough sheet so that we can multiply it well. 35 into 26. So 6 5s are 30, 18, 21, 10, 7. So I will get 910. 2 decimals. So it will be only 9. I hope I have done it correct. I am not very confident. 6 5s are 30, 18, 21, 5 2s are 10, 6 and 1, 7, 0, 1, 9. 9, 1, 0. So 2 decimals, it will be 9.1. My bad. See. Again, 9 6 are 54, 9 2s are 18, 19, 20, 21, 22, 23. So it should be 2.34. And then the last one, 9 5s are 45. 9 3s are 27, 31. So 3.15 in brackets. Let's add all of them and then we shall multiply by 2. So 5 plus 4, 9. 3 4 5 decimal. 3 5 plus 9, 14. So I'm getting 14.59. 9 18, 10 1 11, 8 and 1 9. 2 ones are 2 meter square. I hope you are correct. 29.18. It's correct. Lot of calculations here. You got to be very focused, otherwise you will mess up with all the calculations. So purposely I picked up 1 part 2 which was with decimals. Likewise 2 part 2. Again cuboid, you've been given volume, length and height. Find the breadth. So just apply the formula. Volume is length into breadth into height. So 7.68. Length is 3.2. Breadth is unknown and height is 1. So sending these two down, 768 by 32 into 1. 2 decimals moved, so 100. 1 decimal moved, so 10 is equal to the breadth. Let's see how can I cancel. 16 2 times. 16 4s are 64. So 12 128. 16 8s are 2 1s are 24s are 1 0 goes, 1 0 is left. So therefore breadth is 2.4 meters. There you go. Got it? Yeah, these are all very simple sums. Only the formula should be known. Once you know your formula well, you can easily tackle them. So let's go on to the next one, 2 part 3. Again cuboid. Cuboid, the other name is rectangular parallelepiped or rectangular box, one and the same. So breadth, height is given, volume is given, find the length. So come on, pause this time on your own, get it for me. So length into breadth into height. So volume is 1.92, length is unknown, breadth is 1.2, and height again in centimeters. So convert it to meters, otherwise you will mess up, huh? Remember that. So 0.8. So 192 by 12 into 8. 2 decimals, so I am putting into 100. 1 and 2 decimals, so into 100. So basically all these decimals are taken care of. 12 ones are 12. So 6 times again, 8 ones are 2s. So therefore length is 2 meters. Simple. How many of you all got it? Very good. Write it in the comment section. Let me know who's got it and from where are you. Please write your name as well. Okay. Next one, question number 4. 4 is not difficult at all again. You've been given the ratio. So whenever ratio is there, take the common multiple as x. So this will become 6x, 5x, 3x, that way. So let the common multiple be x. Therefore length becomes 6x, breadth becomes 5x, and height becomes 3x. So once you get your length, breadth and height, now take the total surface area and work it out in order to get this and then the volume. So total surface area is twice length breadth height and height length. So this is given to you as 504. Let's push 2 down. Length 6x, breadth 5x, 5x into 3x, and finally 3x into 6x. So let's see how can we work it out. Come on, pause it right now on your own, get me the value of x, and then we'll try and find the volume. So 2 1s are 2 2s are 2 5s are and 2 2s are again. So 30x square plus 15x square plus 18x square. So I get 252, 30, 40, 50, 60, 3x square. So 252 by 63 is going to be x square. So 63 ones are 63 4 times, 4 3s are 12, 25. Yes, so x will be 2. And therefore we can say length, which was 6x, so 6 into 2, 12 centimeters. Centimeters. Then breadth. So breadth is 5x, so 5 into 2, 10 centimeters. And height is 3x, so 3 into 2, 6 centimeters. Finally, volume is length into breadth into height, 12 into 10 into 6. So 720 meter cube, centimeter cube. 1 mark lost. Yeah, be very careful, otherwise you will lose 1 mark for not writing correct units. This was your sum number 4. 248 is the correct answer. Oh, we got 720. How come? Let me recheck. Sum number 4. Length is 10, 6 and 4. 10, 6 and 4 they got. How come? 1 minute. Let me recheck. 12, 10, 6 correct and 720. It's correct. It's correct. I saw sum number 3. Alright, that's good. If you're getting these sums, you're doing very well. Let's move on to the next one. 5 part 2. You've been given the cube. Length is given. Volume and total surface. So cube, you know that the volume is L cube and total surface area is 6L square. So remember both the things, okay? So let's find the volume, which is L cube. So L will be 2.4. Convert this as meters. So it will be 2.4 meters, the whole cube. So basically 576 into 24. Lot of calculations. 6 4s are 24, 28, 30, 23. 12, 14, 15, 10 and 1, 11. So 4, 2, 5, sorry, 8, 3, 1. So I get 13824. 3 decimals you'll have to put. So 13.824 is what I have got. Am I correct? 13.824 is 5 part 2. And it's correct. 13.824 meter cube. Likewise, the next one, total surface area. So total surface area for the cube is basically 6L square. So 6 times 2.4 square. So 2.4 will be 5.76. Let's multiply. So 6 6 are 36, 6 7 are 42 plus 3 45, 30, so 34 and 2 decimals. So 34.56. Are we correct? Let me just check. Yes, it's correct. Meter cube. Yeah, meter square. Whenever it is area, it will be square, and volume, it will be cube. These sums are not tough, but yeah, a lot of calculations. You really need to be focused. Otherwise, you will easily mess up with the calculations. 6 part 2 cube. Volume is given. Find the length. So you know volume is L cube. So 1.728 is equal to L cube. So L will be cube root of 1728 divided by 1000. Remove all your decimals, so it becomes easy. Now 1728 is basically cube of 12. 12 into 12 into 12 and 10 into 10 into 10, the cube root. So basically it will be 12 by 10 or 1.2 meter. So you need to know, if you don't know, then you'll have to find factors for 1728, okay, and then club them in order to get the cubes. The next one, 7th. Come on, pause this time. On your own, try and see how far can you take this. You have the total surface and you got to find the volume for a cube. So first use the formula of total surface area, find the length, then use the value of length and find the volume. Can you do it? Let's see. So total surface area 216 divided by 6 is L square. So 6 ones are 6, 36 are, so L becomes 6 centimeters. And therefore volume is L cube. So 6 cube, that will be 216 centimeter cube. So you started from 216, you reach to 216 again. Yeah, but this will not happen every time. So don't directly say total surface area as volume. It only happens with few numbers, okay? Let's move on to the next one, sum number 9. Now this is a good question. Put a star besides it. They say that a wall has to be made using the bricks. Generally you see how masons work over there, right? So for a big wall which is 9 by 6 by 20 centimeter thick, you're using small bricks over here. Okay, so how many bricks are needed? So basically you are dealing with volume because you're taking the inner space. So whenever number is asked, so number of bricks will be equal to volume of the wall, the bigger object, upon volume of the brick. Whenever number is asked, volume of bigger object upon volume of smaller object. Let's make that very clear in our head. Bigger upon smaller. So now volume of the wall, let's convert everything into centimeters because here everything is centimeters. So 9 will become 900 and 6 will become 600. So volume of the cuboid, length into breadth into height, both are cuboids. This is going to be 900 into 600 into 20 divided by 30 into 15 into 10. So 2 zeros go away. 15 ones are 15 fours are 3 ones are 3 300s are. So 4 twos are 8 threes are 24 and 2 more zeros. So can you imagine, for a brick you need, for a wall you will be needing 2400 bricks. Oh my god, for one wall how many bricks are needed? Imagine, we never even thought about it, right? Let's move on to the next one, sum number 10. Exactly same type, nothing new, and I'm 100% sure you can manage it. So pause and try it. Cube being melted into smaller cubes. 14 has become 2. How many cubes will be formed? So number of small cubes, same logic we are going to apply. Volume of big cube upon volume of small cube. So we know the formula of cube is L cube upon L cube. So this is 14 into 14 into 14 and this is 2 into 2 into 2. So 7, 7, 7. So 7 cube we know is 343. So 343 cubes will be formed. Please tell me if I am correct. This is sum number 10. Yes, it's absolutely correct. So one big cube made into smaller cubes. How many cubes are formed? 343. Remember, volume of bigger upon smaller is the main logic. Let's move on to our second last question, sum number 11. Cuboid is given with length, breadth, height. You need to find that if you're going to make 20 such boxes, what will be the total cost? So just look at this centimeter, 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 but the cost is in meters. So first convert everything into meters so our life becomes easy. So 40 centimeter will become 0.4 meter. Likewise 30 centimeters will become 0.3 meters and height 50 centimeters will become 0.5 meters. Now let's find one cuboid, how much meter of cloth is needed, not cloth but the metal. So basically we are dealing with surface area, we are not getting inside, so no volume, okay? So total surface area of the cuboid is going to be twice length, breadth, breadth, height, height, length. Lot of calculation, so please focus and don't copy on your own. So 2 times length is 0.4 into 0.3, 0.3 into 0.5 and 0.5 into 0.4, the whole bracket. Don't mess up anywhere please. Multiplying 2 decimals, okay? So 4 3s are 12, so it will be 0.12. Likewise 0.15 and 0.20. So let's add all of them, 20, 30, 47, into 2 should be 0.94 meter square. This is one box. So therefore total surface area of 20 boxes will be how much? So multiplied by 20. So 1 decimal moves off, 4 2s are 8, 9 2s are 18. So 188, 10 and 2 decimals. So 18.8 meters square. And now find the cost. So the cost of all of them is 18.8 multiplied by the cost per meter, which is 45. So let's take the rough sheet, multiplied again, 188 with 45. So 8 5s are 40, 44, 9, 8 4s are 32, 35, 4 7. So 0 6 14 8. 8460, so 1 decimal, so 0.0 rupees. So 846 rupees is going to be the total cost for all the 20 boxes. This is basically for all those people who want to get into visualization. So when you go to a market and if you are buying a box, before that how will they understand what are the cost of the box? The one who has manufactured it. So they will find one box, multiply by 20, so they come to know the cost, then they will sell you accordingly. So basically they wanted to know how much is the material cost, then the labor also will be added. Okay, let's move on to our last question, sum number 12. There you go, the most important one. So please put a star besides it. Very important question. Cube 1, cube 2, cube 3 and cube 4 joined together. So then the shape becomes a cuboid. So this is 9 centimeter, 4 cuboids together. So what will be the total length? So 9 plus 9 plus 9, that will be 36 centimeters. What is the breadth? 9 only. And what is the height? 9 only. So that is the first part of the question. What are the dimensions of the cuboid? You found them. Now find the total surface area of the entire cuboid. So twice length, breadth, height, length. Let's work it out. So 36 into 9, 9 into 9 and again 9 into 36. Twice length, breadth, height, length. So 9 6 are 54, 27 plus 5, that will be 33. Correct? 81, again 3, 34. 9 6 are 54, 5, 27, 28, 29, 30, 31, 32. See, I would have messed it up. So it's always better to cross check. 54, 27 plus 5, 32. Let's add them. 4 plus 4, 8 and 1, 9. 4 plus 8, 12. 6 and 1, 7 into 2. So basically 2 8 9s are 18, 4 and 1, 5 and 14 meter square. 1458 meter square is the total surface area. Now let's get into the volume. Volume is length, breadth, height. So your length, come on, multiply everyone and let's see how well can you take it. So length is basically 36, breadth is 9, height also 9. So it's going to be 36 into 81. So let us multiply 36 with 81. So 6 and 3, 8 6 are 48, 24 28. So 6 11 9 2. So I will get 2916 meter cube. That's exactly what the volume is and it's correct. If you got the same answer, you've done brilliant. For your homework, you must do your homework, otherwise you will not get practice, you will not do any self-study. So pointless. 1 part 1, 2 part 1, 3, 5 part 1, 6 part 1, 7, 8, 11 and 12. This is what I want you to do as your homework. In the description box down, you will see the catalog. For the next year, I am starting for Standard 9 curriculum plan along with doubt solving sessions and test series for Standard 9. So all you people can join that and it's going to benefit you greatly. If you want to join, click the link over there, go to the WhatsApp. If you got any doubts, get in touch with me and I will see you next year. Until the next video when we do the second part of this, that is exercise B. Please take care, stay safe, pray for everyone and be honest. Bye.
I hope you enjoyed the video. Please do write your math experience in the comment section. Thank you.